moving on to problem, actually there's no problem 3. That's all 5-7. That's all you need to know in 5-7 is how to use Pascal's triangle. Moving on to 5-8, we're going to talk a lot about using this calculator. So you're going to have to follow along in the videos, take some notes on the buttons that I push, because a lot is going to be on the calculator. But the first little bit, we'll just kind of talk about. There's this key concept called the n+1 point principle. It's saying for any set n+1 points in the coordinate plane that passes a vertical line test, there is a unique polynomial degree at most n that fits the polynomial perfectly. I know you might be thinking, what in the world? Here's what they're saying. First of all, what I want you to do today is I want you to plot your points. Okay? That'll be your first step, if possible. Step 2, you're going to test and you're going to see if it passes the vertical line test. That's what they're saying, it has to pass the vertical line test. Step 3, you're going to count how many points you have, the number of points, and you're going to minus 1. And what that's going to tell you is that's going to be the maximum degree possible. For example, if I give you 4 points, the maximum degree, okay, if I give you, here's your example, if I give you 4 points, the maximum degree is going to be a 3. That's what that says. Number 4, I'm going to teach you today how to use your calculator to help you. And number 5, you need to be able to look at r squared. R squared is going to tell you how close of a match your equation is to your points. Like, how well does your equation match up with your points? So let's look at problem 1. What polynomial function has a graph that passes through these 4 points? 0, -3, 1, -1, 2, 5, and -1, 7. So the first thing I'm going to do is I'm going to plot my points to see what the heck this looks like. So 0, -3 is over 0, down 3. Over 1, down 1. Over 2, up 5. And last, left 1, down 7. Pause the video if you haven't caught up plotting your points. Now this is definitely not a straight line. There's no way I could take a ruler. So I can't call this thing linear. See how like a straight line doesn't match it? It doesn't really look like a parabola. But what I did notice is that they gave me 4 points to plot. Okay? 4 points minus 1 means it has a max degree of 3. Okay? Which is a cubic. We should notice too that these points are nonlinear, which means it's not going to be a regular x problem. So next what we're going to do is also notice that it passes the vertical line test. It is a function, okay? So we are going to say that this is going to be a cubic. So we're going to go to the calculator. We're going to go to our list. We're going to clear out any points that are on here. Okay, so if you're writing steps, please do on your notes, you want to say clear lists. And we want to put in our x's on the left. And we want to put in our y's on the right. You guys have done this before. This shouldn't be new to you. So I have my points in. Now what I want to do is I want to hit stat. This should be familiar to you. Over to calc. And I'm going to go to number 6 because I believe this one is a cubic, because it has a maximum degree of 3. I get a whole bunch of values, and notice that r squared is 1. I'm going to write that down. R squared equals 1, and that means it's a perfect fit. That's pretty great. So what I'm going to do now is I'm going to write my equation, y equals ax cubed. Well, a is 1x cubed. Plus bx squared. Well, b is -1. So minus 1x squared. C is 2, so plus 2x. And d is -3, so minus 3. There you go. You have the perfect equation that fits all of these points. It is a cubic, and if you notice, guys, look how well that lines up to what you should know is a cubic graph. All right, we'll do the got it together in class, and we'll move on to problem 2. Modeling data. We have the milk production, and that is for 1955, 1980, and 2005. These are in billions of pounds. So in 1955, there was 16.5 billion pounds of milk made in, I think it's the United States, I would assume, but I don't know. Actually, it's just, look at this, it's just for the Wisconsin dairy farms. So this chart shows how much milk the Wisconsin dairy farms produced in 1955, 1980, and 2005. What linear model best fits this data? That's an important word. Linear model. Remember, model is just a fancy word for saying the word equation. Don't forget that anywhere you go. Use the model or the equation to estimate milk production in 2000. So they're asking us to estimate it because we do not know the actual amount. So let's go to our calculators. And this one asks for a linear model. That means a straight line. That means y equals mx plus b. Your calculator uses ax plus b. So what I'm going to do is I'm going to go to Stat, and I'm going to go into your calculator list and clear out what I have already had. I'm going to put in my years in the X column, 1955, 1980, 2005. I'm going to put my Y's over here, 16.5, 22.4, and 22.9. Now, I have my points in. This asks for a linear model, so I go to Stat, over to Calc. I want you to select number 4 this time because that's the linear model. LIN stands for linear. Hit enter, and you'll get these values. Let's write them down. Y equals, our slope is 0.128 with an x, because that's how we write y equals mx plus b. And b is negative 232.84. Now they want us to use this to estimate 2000. So here's our model. Now we need to estimate with our model. Notice that r squared is only 0.81. Okay, we should really note that because it's not that close. Okay, I'm going to write that down. R squared is about 0.81, so it's not too great. All right, but it is an equation. It's an estimate. Okay, but we're using it as an estimate, so I guess it will do. We want r squared to be really close to the value of 1 or negative 1. So now what I'll do is I'll take my model and I'm going to plug in 2000. So I'll say y equals 0.128 times 2000 because that's my x value, that's the year, minus 232.84. So let's plug that in and estimate about how much milk there was made in the Wisconsin farms in 2000. So 0.128 times 2000 minus 232.84. There were approximately 23.2 billion, so let's make this an approximate symbol, billion pounds of milk. And if you look at our data, that fits it pretty good. Yeah, things are going to tend to go up or go down. So it's just, again, it's an estimate. It's not perfect by any means, but we use our estimate to just do that, estimate. Let's do the got it. So here is their model. Our model we did a little differently. They changed like their year equals 0 to be 1955. I did not because people tend to get confused. So let's change our answer so it matches theirs. Don't worry about it. We're going to get the same answers, okay? So use the linear model that we made. to estimate the Wisconsin milk production in 1995 in billions of pounds. Let X, and we're not going to do this last part here because this tends to confuse people. We'll just put in 1995, okay? So we do f of, they want us to plug in 1995 equals 0.128x, and x instead is 1995 in this problem. It's pretty much exactly what we just did above. Minus 232.84. Again, if you guys are wondering why I crossed that off, it's just because it confuses people. We'll just plug in the actual years instead of changing things around because it gets a little confusing if we do. So they want, instead of plugging in 2000 this time, they want us to plug in 1995. We got an answer of 22, so we'll write approximately 22.5 billion of pounds of milk produced. And again, that fits the data pretty well. We'll do problem 3 on the next video.